WAP, wireless access point. What is wireless access point? Wireless access point is a device that provides wireless connectivity for clients in order to connect to the network or to the internet. But don't confuse this with wireless router. They are different devices. Wireless router provides internet connection and also separate one network from another network. But wireless access points provide just Wi-Fi connectivity. That's all. For instance, take our office. Our office consists with 2 rooms. Okay, it's our home or office. We have 2 rooms here. Here we installed wireless router. We got Ethernet cable from provider and have wireless router here in this room, and this wireless router spreads its wireless signal all over the room. But its signal, the strength of the signal, wireless signal, is not enough to reach this room. So in order in this room to have Wi-Fi access, we do the following. We can use 2 methods. First method, we take a LAN cable, our cable, and lay the cable from this router to the second room. We'll lay this cable here and put wireless access point here and have Wi-Fi signals in this room as well. So in this case, as you can see, we use Wi-Fi access points. The main device is our router. The main device is our router. It has antennas as well, and it also, besides the internet, it provides Wi-Fi connectivity. But here in this room we have only access point, only for Wi-Fi. Of course our device is connected to this Wi-Fi, get internet access and connection to the network. Or we can just put some receiver here, repeater here. This repeater is a wireless. We don't lay any cable, don't connect any cable from the router to this device. This repeater receives Wi-Fi signal from this room and increases it and passes it to the second room. Extends the signal and passes it to the second room. Okay, now we have 2 options. But in this tutorial I'm going to discuss wireless access, not repeaters, just wireless access points. Wireless access points work at 2 frequencies. It's 2.4 gigahertz and 5 gigahertz frequencies, 2 frequencies. Some access points supports both of them, some access points supports only one of them. The 2 and 4 gigahertz frequency, the waves working on this frequency are very long, but they are a little weaker than 5 gigahertz. 5 gigahertz waves are more stronger than 2 and 4 gigahertz, but they are short. But actually, most of the devices using 2 and 4 gigahertz, they are working at 2 and 4 gigahertz frequency. For example, access points, wireless routers, even microwave ovens, Wi-Fi phones, Wi-Fi web cameras, etc., etc. So try, if you're installing access points somewhere, try to install these access points a little far away from microwave ovens, from Wi-Fi phones and Wi-Fi cameras, because they can interfere each other, and we may have a lot of problems in this with connectivity. Also, there are 4 channels, Wi-Fi channels we can use. If you configure any Wi-Fi access point, every Wi-Fi access point has 14 channels, but when we configure this Wi-Fi access point, the mode of this channel is automatic by default. So each access point choose these channels automatically by default, but we can assign these channels manually as well. Why we need to do that? We need to do that. Let's look at this graphical. We have several channels here. First channel, second channel, third channel, fourth channel, fifth channel, sixth channel, 11, 12, etc., etc., right? So first channel sends waves, wireless waves in this interval from here somewhere to here. Just let me show like this. From here, just here. It's an interval. It's a zone. It's a Wi-Fi zone for this channel. Wi-Fi zone for the second channel is from 2 till here. For the third channel, from 3 till here. For the fourth channel, from here to here. 5 from here, etc., etc. So if we have several devices which are close each other, which are next to each other and very close to each other, so if we put channel mode, if we leave it by default, or we, for example, for our first device, we put channel 1 in this device manually, second device is next to it, we put channel 2 on the third device is also next to second device, this device broadcasting in channel 3, for example. So which problem we can have here? As you can see, this difference between first and second channel, these two channels cross with each other. As you can see, there is a space between them. There is a space between them where they're crossing each other. First channel crossing second channel, third channel crossing fourth channel, and etc., etc. So these zones are called dead zones, where we have bad signal. We have bad signal in these zones. When our devices are next to the zones, so we will have a lot of problems with connectivity. We'll lose signals and they'll have slow connection and so on. So if my device, so this is here are 3 access points: first channel, second channel, third channel, and I have my device somewhere here, my smartphone, for example. So this device, its Wi-Fi zone covers this place somewhere here. Wi-Fi zone of this device covers from here to here, somewhere here, and the Wi-Fi of this device covers from here to here. Okay, somewhere here. So where is my first signal? It's here. It's here, my first and my second. Can you see the zones of first and second crosses here, somewhere here, somewhere here. This zone is a dead zone. When my smartphone is here, everything is fine. I can connect to this access point and everything is fine. But if I have my devices in the zone, so my devices located in the zone, would have some problems with connectivity because they are located at the dead zone. To avoid these, we use clean channels. As you can see here, clean channels. For instance, first channel, sixth channel, 11th channel. Why they are clean channels? Look, if we take this diagram, first channel, second channel, third channel, fourth channel, 5, 6, 11. If we have several access points which are located very close to each other, next each other and close to each other, then it's recommended to manually use clean channels. For instance, one my device access point uses first channel, this, yes. Second my access point, which is very close to my first access point, second access point uses sixth channel, okay. Third access point uses 11th channel. Why? In this case, we don't have dead zones here. We spread these channels. We created very long intervals between these channels. So in this scenario, in this case, our clients will not have any issues. Because these channels, first and sixth channel, don't interfere with each other, don't cross with each other, and 6, 11 channels don't interfere and cross with each other either, right? So in this scenario, if we have several access points which are very close to each other, we use clean channels. For instance, if I put access point here next to this access point, how do you think, which channel should I assign to it? Of course not 2, of course not 3, yes? Most probably 6 channel, right? These two access points, this and this access point, are far away from each other, so they don't cross, they don't interfere with each other. So it's not problem, it's not issue. If I have access point here, I'll assign, for example, 1 or 11 channel. And I have access point here, which channel I should assign? Of course, 6th or 1. Here we have 6, and so on. I hope you got it. You got this point. So pay attention on this when you are configuring access points, especially if they are located very close to each other. Okay, access point can work as a standalone access point and can use controllers to configure. What is standalone mode? These are modes of access points. Standalone modes means that when I unpack a new access point, I connect to this access point directly and configure it from this IP address or hostname and so on. I connect to each access point and configure it. For example, if I have one access point or 4 access points, not much access point, not main access points, sorry, not main access points, not 1, 2, 3 or 4, few access points in our small office, it's okay to use them to configure them as a standalone access points. I connect to each of these access points, create SSID, create password, and do a lot of things. Connected to each access point and configure them. Yes? Okay. Then my boss asks me to change Wi-Fi password or change SSID name or add another SSID. What should I do? I should connect to each of these access points to configure them, right? Right. But what if I have 50 access points, 100 access points? What should I do? If my boss asks me to change Wi-Fi SSID or Wi-Fi password, it will be big pain. It will be awful, very difficult for me to do it. In this case, I should to connect to each 50 or 100 access points and to configure them. It's crazy, right? So in this case, if we have a lot of access points, we use controllers. There are 2 types of controllers. First type is application controllers, software controllers. Second type is hardware controllers. For instance, there are some companies TP-Link, for example, TP-Link, Ubiquiti, Ubiquiti access points companies, which provides, when we buy products from them, when we buy access points from them, we've got software-based controllers. It means that we have several access points. We have one computer. We need one computer for software controller. We install this software control into this computer, configure everything here, SSID name, password, security, etc., etc. We configure everything in this computer, everything we need for Wi-Fi, and just connect our new unpacked access point to the network. We have a switch here. Connect this access point to the switch, and this computer also connected to the switch. We connect them, provision them, and all information from this software-based controller is synchronizing and replicating to these devices, and these devices got all information from the controller. Everything, that's all. For example, I bought a new access point, additional access point. What I do? Just plug this access point in the switch, go to controller and provision this. Okay, just get familiar with this access point with our systems. That's all. I press provision, for example, provision, and this access point automatically pulls all information from controller to the hardware. That's all. If later I need to change Wi-Fi password, I need to create additional SSID, I need to change SSID name, etc., etc., I just log into one place. For instance, we have 50 access points. I don't connect to each other. I log into one place, to my controller, software controller, change Wi-Fi name here, there, change Wi-Fi password there. That's all. All information is synchronizing with our devices, and that's all. It's very easy. That's why we need controllers in large companies where we have a large infrastructure. Also, we have hardware-based controllers, like in this picture below, Cisco hardware-based controller. It's the same thing, almost the same thing. We configure this controller and just plug our access point to this controller. That's all. Also, I want to give brief information about wireless standards to you. We have, it's the first wireless standard, 802.11b. It's the first, it's the old wireless standard. Then we have AGN standard, and the latest standard is 802.11ax. So to get rid of these codes, it's difficult to remember these codes. Good people created the new names, new short names for the standards. For instance, standard 82.11ax is called just Wi-Fi 6. If you say Wi-Fi 6, you should know that this Wi-Fi 6 means 802.11ax standard. Also, I want to mention one main thing. As you know, switch has several ports, and each port of the switch is an isolated port, right? Isolated collision domain. It's called collision domains. Each port it's a collision domain. So, for instance, if each of these ports have speed, for example, 100 megabit per second or 1 gigabit per second, right? So, if I connect some device here, my smartphone, no, not smartphone, for example, my laptop, it can use this port, it can use 100 megabit speed here, right? If I connect second device to the switch, it also can use its full speed of this port, 100 megabits per second. At the same time, So the more devices I have connected to the switch, the more things we can do, the more speed we can use. It means that I connect this device, it can use separately. It's 100 megabit for this, or 1 gigabit. Its speed. This device is using its speed without any problem. These devices don't interfere with each other, right? So I can connect a lot of devices here, and each of them using their speed, 100 or 1 gigabit speed, without any problem. But in access points, the situation is quite different. Access points, as we are using channels, and frequencies. If we take access point here, so we cannot, our clients cannot use this Wi-Fi at the same time. If one of my clients connected to this, my smartphone is connected to the Wi-Fi of this access point, and transmitting some information, sending, receiving, and doing something, the second smartphone should wait until this smartphone finishes its work. Okay, as soon as it's finishing its packet receiving or packet sending, the second smartphone is starting its work. The same situation with the third device. So here we have a little queue. So the more devices we have connected to the wireless access point, the lower the speed of the network. Keep in mind. So try to not use Wi-Fi everywhere. Try to use cable connection, especially if you have servers, if you have desktop computers, if you have printers. Try to use cable connection if it's possible. You can use wireless for example for guests or for mobile phones, smartphones. It's okay for such kind of devices, but for the work, for the real device, even for your laptops, try to use LAN connections, because Wi-Fi, despite on the speed of Wi-Fi, you can see on the box that speed of connection is 300 megabits, 700 megabits, etc., etc. Despite of that, it's not real speed, because you already know that there is a queue. The access point cannot provide separate speed as switch to. Switch provides separate speeds from each of its ports. 100 megabits for each port. If this switch has 48 ports, it means that 48 devices can connect to this port, and each port will use its own separate isolated speed without any problem. But in access point, it's a little bit different. It has as if switch has shared ports. Access point has shared channels, shared frequencies. These ports are shared between these devices. So the more devices we have connected to the access point, the lower is the speed of the wireless connectivity. That's it for now. Thanks for watching.